All right, homework out, if you would, please. Books open to page 144. It gave you 4 problems to work. And numbers 1, 3, 7, and 18. Number 7, there were a few different ways you could have worked it. You didn't have to use a double angle identity. But the point of these problems was to get you to use the double angle identities or multi-angle. And said really the key in working with the multiple angle was that when you get your first set of answers, you don't stop there, but you go around again. And then if it's triple angle, you go around again. And perhaps keep going around until you've gone around the Cartesian plane as many times as your n value is, your multiple angle is. And then at the end, of course, divide out that n value. So, for instance, on number 1, really straightforward, we got the cosine of 2 sigma equals 0. Well, anytime we see a 0, I told you, let's go ahead and put it over. And let's also put a plus minus on there. So the question comes, we've got the trig function isolated. When is cosine 0 over 1?
90 degrees.
90 degrees. But because of the positive negative, let's say both 90 and
180 or
270. 90 and its inverse, which would be 270. But that's not sigma, class.
That's 2 sigma.
That's 2 sigma. So because it's a 2 sigma, I'm going to have to go around a second time adding 360. So I'm also going to get
450
and 630. But those are all 2 sigma. The reason I add 360 is so when I divide away the 2 to get my answers for sigma, I've got all the different possible answers that satisfy. And what do my answers end up becoming here? A familiar set of answers.
45, 135, 225, 350.
There we go. Pretty straightforward. Now, is this the only way to do it? No. You could have expanded this out and said, well, this is 2 cosine squared sigma minus 1. Right? That's one of our double angle identities. Add the 1, divide the 2, take the square root. When is cosine square root of 2 over 2? At 45. When's it positive, negative? All 4 quadrants. Could have done it that way as well, but we wanted to get the practice with the 2 sigma and then dividing out the 2. How many got these answers on number 1? Questions?
I forgot to add 360.
Yeah. Forgot to add the 3. So you got the first 2 answers, you just missing the second 2. So a reminder, go around a second time. Let's take a look at number 3, and this one required a little bit of creativity. The tangent 2 theta equals the sine of 2 theta. And I said, anytime we have multiple trig functions, what's my strategy, class?
Set equal to 0 factor.
Set equal to 0 factor. So to set equal to 0, one of these has got to move. Which one did you want to move, Ethan?
The sign.
The sign? So we'll move it over as a negative, so it's set equal to 0. But the way this is written, I can't factor anything. Thoughts, Jamie?
Double angle identity?
Well, if I do, this is going to be 2 tangent over 1 minus tangent squared minus 2 sine cosine. There's nothing that can factor there either.
Tangent sine cosine.
Oh, but if I change this to sine 2 theta over cosine 2 theta minus the sine of 2 theta equals 0. By the way, if I do this, and that's the right approach to take, I do need to make one little qualifying statement.
2 theta can't be 0.
The cosine of 2 theta can't be 0. Okay, so if we could double the answer and get a cosine of double the answer equals 0, that's no good. And now, what can I factor out, Chris?
I got a comment wrong.
We don't even have to do that. There's something common already.
Sorry.
There's a sign, because again, the goal is to set it equal to 0 and factor, but here's where it gets a little interesting. What do I get if I pull a sine out of a sine over cosine?
1 over cosine.
1 over cosine 2 theta, excellent. And then if I pull a sine out of a sine, 1. And I could say, well, 1 over cosine, class, could just be written. So this is the way I did it. It's not the only way to do it, but I went to secant 2 theta minus 1 equals 0. And now it looks similar to what we've seen before. Does that make sense? Question.
What I did is I put the sine 2 theta over 1, and I got a common denominator, so I got sine. I see what I mean.
Well, again, and it wouldn't be wrong, by the way, to multiply everything by cosine to get sine 2 theta. Again, let me show it. Multiply everything by cosine 2 theta, cosine 2 theta, cosine 2 theta. And that's going to cancel here to get sine 2 theta. Here it's going to be minus sine 2 theta cosine 2 theta. and then here equals still a 0. Then I could still factor out a sine 2 theta, but it's going to leave me with 1 minus cosine 2 theta instead of secant 2 theta minus 1. Okay? It's going to come out with the same answers either way you work it, though. And we'll see why here in just a moment. In either case, once we've gotten to either one of these points, I need to set the factors equal to 0. So in either case, class, we're going to get that
sine 2 theta equals 0.
and then here, we're either going to get that the secant 2 theta equals,
Positive 1.
or we're going to get that the, move this over, that 1 equals the cosine of 2 theta. But think about it. Secant and cosine are reciprocals, right? But what's the reciprocal of 1?
1.
They're both the same statement. They're going to get you to the same point. Either hypotenuse over adjacent or adjacent over hypotenuse. It's going to be the same thing, right? So that's how you get out of it. Of course, the 0 over needs a... All right? And that's going to be true in either case, right? Where the 1 does not get the positive negative. Okay, question. When is sine, opposite over hypotenuse, 0 over 1?
0.
At 0. So that means 2 theta is going to equal 0, and because of the positive negative, not just 0, but also 180. But because it's 2 theta, gotta go around again, class.
360.
360 and
520.
540. 540. Here, when is secant 1 over 1 or cosine 1 over 1? It's the same answer.
90.
Or no, 0.
At 0 also. But only 0, not 180. So either the cosine of 2 theta, or either 2 theta equals 0 or 2 theta equals 0, right? It's the same answer either way, but not the 180. Well, we've already got a 0, so I mean, yes, we could add 360 to it. It's going to be the same thing. So this is just a redundancy. We don't actually need it. Does that make sense? Did I lose anyone yet? This weird feeling like I lost somebody. Y'all still with me? All right. That's 2 theta. I just want theta.
0, 90,
180.
230.
And there we go, all 4 quadrantals. Now, question. If you doubled any of these and tried to take the cosine, would it give a 0? Well, what's double 0?
0.
What's the cosine of 0?
0.
1. So we're good. What do you get if you double a 90?
180.
180. What's the cosine of 180? You can test it on the calculator. -1. Right? Well, we're good there. If you double 180, it gives you 360, which is the same thing as 0, and that checked out. If you double 270, it gives you 540, which is the same thing as 90, which, again, already had checked out. So we're good. Questions on this? All right. Double 270 is 540, which is the same as 180, which we'd already checked out to work. So there we go for our answers. All 4 answers do check. Questions on that one. A little creativity with the sine over cosine, and then either factoring it out to get 1 over cosine minus 1 or secant minus 1, or multiply everything by the LCD and then factor out the sine. Same answers either way you work it. Number 7 I thought was a little more straightforward, but there were 3 different ways you could approach the problem. What did you do on number 7, Quentin?
I changed the cosine squared chi minus sine squared chi to 2 cosine chi.
You mean cosine 2 chi?
Yes.
Yeah, there we go. That's the double angle identity, right? Cosine squared minus sine squared is double angle. So this becomes cosine 2 chi equals 1. Super easy. We put the 1 over.
1.
We remember the SIGN is,
Positive.
but not positive, negative. We say when is cosine 1 over 1?
0, 0.
At 0, but not 180. So we say the 2 chi is just 0. Except we have to go around again.
360.
And then we divide away the 2.
180. 0, 180.
And there's our answers. That's one way to work it. What's another way to work it?
I don't know.
Easiest way.
Does everyone do it that way? This to me is the easy way. And everyone do it this way? Jamie, you did not. What did you do?
I was changing the cosine to 1 minus sine squared.
Ah, very good. So we could say 1 minus sine squared chi minus sine squared chi equals 1. Then what did you have to do?
Then I combined and got 1 minus 2 sine squared chi equals 1. and it moves the 1 over, and it becomes 0. 2 sine squared pi, and then divide away the 2. That's where I got stuck at.
So what do you get if you divide 0 by 2?
Oh, 0.
0. And we can make that and then when you take the square root of both sides, we get that the sine of chi is equal to,
Square root, well,
what's the square root of 0?
0.
So, 0. And put a positive negative over 1. When is sine 0? At 0. And the negative would be 180. Same answers. The other way you could have done it was change this into 1 minus cosine squared. It would have been very, very similar. 1 minus cosine squared. They would have cosine squared minus 1 minus cosine squared. Go from there. Questions on this? All right. How many got that again? Got it? Take a couple of them. All right. We good now? Number 18. And we have 2. Cosine 3 phi equals square root of 3. Chris?
I made it cosine of 3 theta equals square root of 3 over 2.
Good. And now we've isolated the trig function. When is cosine adjacent over hypotenuse square root of 3 over 2, class?
30 degrees.
At 30 degrees. But ASTC, notice it's not positive negative. It came as a positive. When is cosine positive?
First and fourth.
First and fourth. So that means 3 phi is equal to, in quadrant 1,
30.
and in quadrant 4,
330.
all right, someone besides Chris, it's a 3 phi. So I have to go around again. And then again after that. But let's start with the first again to get.
390.
And,
690.
all right, Ethan, your turn. I got to go around again.
I'm not going to try to do that.
You evidently did not do this last night.
No,
All right.
I just did different. I did it wrong.
Okay.
750 and 1050.
Right, okay, and so that's all 3 phi though. I don't want 3 phi, I want phi. So
Yeah, I did.
now what do I have to do at the end, class?
5 by 3.
Everything by 3 to get.
Yeah, I did. 250. Yeah.
And there we go. 10, 110, 130, through 30, 250, and 350. Of course, degrees on all of those. Don't want to lose little points for those. How many have those 6 answers?
I just didn't put the 30 through 30. I just in my head.
Ah, okay. Questions. All right. So again, we looked at this yesterday briefly. So this was really your first chance to try it on your own. Do we feel like we got a good understanding of what to do with the multiple angles if we see them?
Yeah.
All right. Now then, let's take another approach with the multiple angles that we may see. Write this problem down in your notes if you would, please. Cosine 2 phi. Actually, we just did phi. Let's mix it up. Let's go with
Gamma.
gamma, okay? So cosine 2 gamma is equal to negative 3 cosine gamma minus 2. Now here, I want you to notice, you have single angle and double angle in the same problem. You can't work with single and double at the same time. Write that in your notes. If you have single and double in the same equation, you must simplify with a double angle identity. If you have single angle and double angle in the same equation, you must simplify using the double angle identity. So I've got to change this. I can't keep a double angle where there's also a single angle. You can't have, they don't coexist, okay? So there's 3 ways though I could change out cosine to gamma. What's one way to change out a cosine double angle?
Cosine squared minus sine squared.
Cosine squared minus sine squared. But here's the problem. I would have a cosine squared and a sine squared and a cosine all at once. Okay, what's another way to change out the cosine to gamma?
Cosine squared minus 1. Or 1.
2 cosine squared minus 1. Now notice, this would give me a cosine squared and a cosine to the first. That's just complete quadratic. What's the last way I could change out a cosine double angle?
Couldn't you make it cosine over cosine? Cosine gamma over cosine gamma? Or no?
That would be 1.
Um,
How about 1 minus 2 sine squared? Is the other way, right? By the way, do you understand what I'm pointing out here? You have to remember your trig identities. We did a quotient identity earlier. She used a Pythagorean identity earlier. We're using double angles here. We've got to still remember the identities. We're just not verifying identities. Again, your strategy is which of these is the best choice, because this side only has regular cosines. Let's go with the one that only has cosines, not sines as well. Does that make sense? So that gives me 2 cosine squared gamma minus 1 equals negative 3 cosine gamma minus 2. Now it's a quadratic. Set it equal to 0. Let's bring everything over here. What is it simplified down to, Ethan?
It simplifies down to 1 2 cosine squared gamma plus 3 cosine gamma equals 1.
Well, we're bringing the 2 over as a positive 2, so positive 1 equals 0. Remember, the whole point was you're setting it equal to 0.
Oh,
So what's
yeah, I didn't mean to say equal. I meant to say that. But.
All right, so once it's set equal to 0, now what?
Factor.
Factor. All right, Quentin, how would we factor it?
Cosine squared, cosine squared.
I'm sorry, how?
Cosine squared gamma, cosine squared gamma.
Well, that would...
Or...
Cosine squared and cosine squared would be cosine to the 4th.
Cosine and cosine.
Well, cosine and cosine would be cosine squared. I wanted 2 cosine squared.
Put 2 in front of 1.
There we go. 1 cosine and 2. It's been a little while, right? So if I had a 2x squared, I'd say x and 2x, right? So it's 2 cosine squared, cosine and 2 cosine. What about my sines, Quentin? Both going to be positive, and the only way to split up a 1. All right, this better work then, or else I'm stuck with the quadratic formula. Oh boy. All right, does the outer inner check to give me a 3 cosine class?
Yes.
Okay, so that means I can set each of these equal to 0, and I'm going to get 2 little mini equations now, Chris.
Cosine equals negative 1, and then 2, or cosine equals negative 1/2.
Good. I'm going to take the negative 1 and put it as a 1 over 1. And then I've got my trig functions isolated. When is cosine 1 over 1 class? At 0. Right? Adjacent over hypotenuse.
Oh, yeah.
Right? That's going to be at 0, but it's the negative of 0. 180. So here gamma is only equal to 180 degrees.
Wait. How is 1/2? How does it equal 0? 1/2?
Negative half. You bring the 1 over as a negative, and then divide away the 2.
Oh, okay.
All right, now we're going to ask, speaking of which, when does cosine equal 1 over 2 or 1/2?
45?
At 60. But it's negative. When is cosine negative?
2 and 3.
2 and 3. So I need the 2 and 3 forms of 60. 120.
And then
240.
240. And there are my answers. So this one, we didn't actually have to do any go around with adding 360 because I never had a 2 gamma equals, right? So I didn't have to add a 360, I didn't have to divide by the 2 because I actually got rid of the double angle right up front. I needed to because I also had a single angle. Does that make sense? All right, let's look at some more of these then. Let's take a look at number 4 in your textbook. We've got the cosine, well, there on page 144. We have the cosine of 6 rho equals negative 2 cosine squared 3 rho. This is kind of similar to the last one where you can't have different angle levels. Here I've got a 6 rho, here I've got a 3 rho. You can't do that. They've all got to be the same row. So in this case, they all need to be triple row, 3 rho. How could I rewrite 6 rho in terms of 3 rho?
You could, I was going to say you could divide the, no, you never did that. Cosine 3p.
On 3 rho.
3 rho. Plus cosine 3.
Well, I can do 3 rho plus 3 rho. But then I'm stuck with a cosine, cosine, sine, sine, sine. Maybe there's a better way?
Cosine 2 times 3 rho.
Yeah, 6 rho is merely twice 3 rho. So cosine of twice 3 rho equals a negative 2 cosine squared 3 rho. And we actually did this in a verification, I think, once before, where I rewrote it like a quadruple angle is double a double, where I'm writing a 6 angle as double a triple. And so this is a double angle identity. So I can pick one of these 3 forms, either cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Which one?
Cosine squared minus 1.
The 2 cosine squared minus 1. But instead of 2 cosine squared rho, it's a 3 rho. So 2 cosine squared 3 rho minus 1 equals negative 2 cosine squared 3 rho. Did I lose anyone? Who's following?
Yeah.
All right, now then. They're both the same level of angle. They're both triple angle. Now what?
Say equals 0.
Okay, I would say this. I've got a cosine squared on this side. I've got a cosine squared on that side.
Cancel.
Well, do they cancel? Are they exactly the same?
No, they're positive, negative.
Well, but together, positive and negative cancel. On opposite sides, you get rid of the little one.
The negative 2 cosine.
Right, bring it over here as a positive 2 cosine squared 3 rho, and they're not going to cancel. They're actually going to amplify each other to get a,
4 cosine squared 6p.
real careful, 4 cosine squared 3 rho. I've got 2 cosine squared 3 rho plus another 2 cosine squared 3 rho gives me 4 cosine squared 3 rho. Minus 1 is equal to 0. Again, we did kind of set it equal to 0, though we're not going to leave it this way because we're not factoring here. Instead, we're going to isolate.
So move the 1 over, divide by 4, take square root.
To get cosine of 3 rho equals
1/2.
Negative, or positive.
positive negative a half. Add the 1, divide the 4, take the square root. That's where we got the positive negative a half. Are we still with me or have I lost somebody?
Yep.
We're all still good?
Yeah.
Now we've got it isolated and we simply ask ourselves, self, when is cosine equal to a half?
60.
60. When is cosine positive negative?
2 and 3.
All.
Or all.
All of them. So my 3 rho, brace yourself, is all 4 quadrants. So
60, 120, 240, and 300.
but this is a 3 rho.
Add 360.
So we're gonna have to hit 360.
420, 5, 480, 5, 600, and 660.
But because it's a 3 rho,
Add 360.
I gotta add 360 that second time, so I get 1, 2, 3 trips around the Cartesian plane.
780, 140.
Remember, just adding 360,
Oh,
not 140.
580.
840.
Yeah, that's right.
960 and 1320.
Careful.
another 120.
1020. 1020.
Oh.
So it's 1 trip, 2 trips, 3 trips around, but that's all 3 rho. I don't want 3 rho. I just want
Yeah.
rho. So what do I have to do with all my 3 rows?
3.
Divide them all by 3. What do I get now?
20, 40, 60.
Careful.
80.
80.
100. 140.
120.
Dividing by 3, not by 4.
160.
160.
200. And 230. Or 220.
All right, last set. We need to divide by 3.
260.
Calculator to the rescue.
280.
320.
340.
And there we go. There are my 12 answers for rho. Yes.
So I just realized on the 20, like, say you're going out 20, you got 20, 140, 260. You're just adding 120 every time.
I was actually about to point that out. Very good observation, Chris. Here's what I would normally do. I wouldn't find all of them. I'd get my first trip around, add 360, skip those, add 360. Cut these all by a third, divide them all by 3. Just to make sure my brain's thinking right, divide that by 3. But sure enough, you notice it's just adding 120, right? After all, if you add 360 and divide that same 360 by 3, that's really adding 120. Add 120 to
I
all
was
of
thinking
those.
that earlier.
Divide this by 3 just to make sure, yup, that's just another 120, which mathematically makes sense. Add 120 to all of those. And it's a little quicker way to go about it. Now, what we did together a moment ago is really the best way, but mathematicians are lazy, and Chris lived up to the hype there. His lazy self noticed, wait, there's an easier way. Well done, Christopher, new favorite student. All right, questions on this? Yes.
So I want to go check, how do we go from the 4 cosine squared to the cosine 3p? Do we do the square root?
All right, so we add the 1, we divide away the 4, we take the square root, and the square root of 1/4 is 1 over 2 with the positive negative. Yep, great question. Good. Any other questions on this one?
Pick up these figures.
No, we're not ready for that yet. Let's take a look at number 6. Number 6. Notice no double angle here.
It's gonna be hard, watch it.
This is easy. I already know how to do this one. This one's easy.
All right, Chris is on a roll with his mathematician big brain. Christopher
Big
is
brain.
very confident he's got this. Chris, what do we do?
Make it cosine over 1 over cosine.
Good. Let's start by rewriting the secant as 1 over cosine. By the way, that denominator of cosine needs to be set unequal to
0.
0. Okay, so we've got to better make sure that cosine can't equal a 0. All right?
Then you flip it and you get cosine squared rho equals 1. And then you take the square root of 1, which just gives you 1. Put that over
Well,
1.
does it give you 1 when you take the square root?
The square root of 1, yeah, it gives you 1.
He's half right.
Positive, negative.
Positive, negative 1.
You do positive negative 1 over 1. And you know cosine equals positive negative 1 over 1, and that's 0 degrees.
Yes. And because of the negative,
180.
180. And we're done. By the way, the cosine of these angles equals 1. The cosine of these angles doesn't equal 0. Both answers are good to go. It checks. No double angle in this one. They just threw it in there just to give us a bit of a break from double angle. Y'all like that?
Wait, so it has positive negative, so why is there only 2 answers?
Well, because it's a quadrantal. So normally in a quadrant here you got 4 quadrants, but a quadrantal 0 and 180 are the only 2 zeros, and 90 and 270 are the only 2 90s. Whereas there's 4 different 30s, 4 different 45s, and 4 different 60s. Does that make sense now? All right, good. Any other questions? Great question. All right, let's look at number 10 across the page. Number 10 across the page, where we have secant 2 omega equals 1 minus 2 sine omega. By the way, with this, I couldn't help thinking as we're to the Omicron variant of coronavirus now, right? Omicron?
What is it?
Omicron, what does it look like?
I've never heard of it. I don't know what it does.
That.
Like, what's
And
different?
a capital is that. Oh, as far as the variant, I don't know, it came out of Africa. So there's an Indian variant, the Delta variant came from India, the Omicron variant's coming out of Africa. I have no idea.
The hot dog variant's gonna come out of America.
I don't know. But you know, we're working through this Greek alphabet pretty quickly, right? You know what all these things look like, except we've never used Omicron because it looks like a 0. So we do
The hot dog variant.
hot dog variant. Now, I mean, maybe if once they get to zeta, I guess, then we do we don't use zeta in this class because capital zeta is easy, but we never use capitals, right? That's capital zeta. Lowercase zeta is it's like I don't even know, it's like a squiggle or something. It's really strange. I can't draw it, so we just don't use zeta in this class. You can Google it if you want what it looks like after class, but yeah, we don't.
We
I
can't
can't draw alpha. We can.
After school, you can Google
After school,
what
yeah.
zeta looks
My
like.
alpha looks like
Lowercase
infinity
zeta.
sign.
What?
My alpha looks like an infinity sign. I can't do it.
It actually looks like an A. You come down.
Guess what?
There's a little bit of a tail. That's all. It's just an A with a little tail and a thing that sticks up first.
I can't do beta. It ends up looking like a beta.
Now, if you draw it like that, I mean, that's a really lousy looking alpha.
Yeah, that's what I think.
That's
Kind of looks more like a fish than an alpha. But anyway, I digress. Thoughts? We got single angle, we got double angle.
Get rid of double angle.
Gotta get rid of double angle. But what is the double angle for secant?
Reciprocal of cosine.
Reciprocal of cosine. Now, that means we're going to do 1 over something, right? But remember, there are 3 different variants of the cosine double angle. Which variant should we use?
1 minus 2
1 minus 2
sine
sine
squared.
squared.
Good. 1 minus 2 sine squared omega. And at the same time, I'm going to put this over 1. Before I get ahead of myself, though, we just created a denominator.
Set it equal to 0.
Can't be 0.
Can't be 0. So when I set that unequal to 0, what does it end up saying?
2.
Move it over. I mean, it's a positive. So 1 equals.
Negative.
Divide the 2. Take the square root.
Mechanical 1/2.
Sine of omega cannot equal.
Positive, negative. Or,
Right?
mhm.
Move this over as a positive 2 sine squared. Divide the 2. Take the square root, square root of 1 over square root of 2, or 1 over square
Oh
root of 2.
yeah, I was thinking the 2
positive.
and 4.
Right. All right, so sine can't be 1 over square root of 2, which means no 45s, right? Because that's when sine would be that. So if we get any 45s, those have to be ruled out. All right, but if I take the time to put this over 1, I just turned this thing into a
Proportion.
proportion.
Oh,
How do I solve
I got
a
it.
proportion?
Cross multiply.
Cross multiply. Let's start with the extremes because they're easy.
1.
1.
Go ahead.
You got the hot dog here?
Now for the means.
First out.
When again we cross multiply the means? First,
1,
outer,
negative 2.
negative 2 sine, inner,
Negative 2 sine squared omega.
Yeah, it's
last.
Positive 4 sine cubed omega.
Good. Now, I notice y'all backed out and let Quentin take charge.
Well done.
Do you understand how we did that?
Yes.
Good. No. All right. Thoughts?
Put it in there.
Let's get ourselves.
Or
Well, something Ethan wanted to do on the last problem. I expected him to
Why
jump
don't
in.
you just do it like grouping?
Well, because it's not set equal to 0 yet.
0 first.
All right, we'll move the 1 over, or divide it by 1.
Divided by 1? Oh, that's not how we set equal to 0. Because if you divide by 1, it still equals 1.
Subtract by 1.
Subtract away the 1. Or move the 1 over as a negative, but really that ends up doing what? Yeah, that's what I was expecting Ethan to say. Just cancel the 1s because they match. So that this side becomes a 0. Let's rearrange that in the descending order. So we have the 4 sine cubed minus 2 sine squared minus 2 sine. And all of a sudden, what I was originally thinking when I saw the problem as well, I was thinking grouping. I can't group anymore, can I?
Factor out of 2 sine.
But there is a common factor, 2 sine omega. So let's work our way through here with the common factor first. Pounding that into my Algebra 1 students at the moment. What does it leave me with when I factor out the common factor?
2 sine squared omega minus sine omega minus 1.
All right, Quentin is now banned from answering. This is my answer ban.
Yeah, I should be answer banned too after doing those other stuff.
All right. Okay, Jamie, I haven't heard your voice in a
Distribute.
while. No, we don't want to distribute. We're factoring. We set it equal to 0. We're trying to factor distribution. We'd undo all of our work. Just trying to undo Quentin here. All right.
Quinn's like this too.
Jamie. Jameson's. That was last year.
Jameson's?
That was last quarter.
That was last quarter?
No, what was last year?
Did Jamie and Genesis end up on the same
Quinn,
team?
where are you?
Jameson's?
No.
Shout out to Genesis. All right, Jamie.
I would say I had too many equations, but there's still, that's too long over there in the parentheses.
Right, I can still do more factoring, right? If this were a 2x squared minus x minus 1, I could backwards FOIL that, right? Or at least it looks like it could. Or I'd have to use the quadratic formula. All right, so
I don't even remember.
Why'd you call it that?
Why have to use the quadratic formula?
you don't remember the quadratic formula?
Oh, sure.
Well, let's go.
No.
All right, I will not punish you for Chris's behalf. If I find 3 in the class who can do the factoring method, I will not make you do that. All right.
It's like I have to do the
Like
quadratic formula the rest of the entire year.
All right, so Jamie.
We have 2 sine and 1 sine. And we'll have our alternating things, yeah.
Alternating SIGNs.
Yes, and then 1, and now we gotta double check that's right. And let's see, it's 92. And it'll be right.
Yeah.
Mhm.
Out backwards FOIL works. Outer inner checks. We got the -1 sine omega. Great job, Jamie. So now, Jamie, not 2 equations, but
3 maybe.
3 equations. Name all 3 equations.
Well, we're gonna have the 2
Wanna
sine omega, and that will become 0 over 2.
Well, 0 over 2, 0 over 1, 0 over anything is just 0 anyway. So I'll just call it 0 over 1. Positive, negative, by the way.
Negative. And then we're gonna have the 2 sine equals -1, then divide that by 2, so it's -1/2.
All right.
And then we're also gonna have sine equals +1 over 1.
All right. By the way, in any of these, did we get 1 over square root of 2?
No.
All right. So that means all of these are going to be good. Okay. So that's it.
I wish you kind of went over square root of 2.
No, you really wish one of them had been. I could just cross it out and not worry about it, but now we're stuck. All right, so when is sine 0 over 1?
0.
0, but we don't positive and negative.
We
I'm
have
banned from answering.
0. 1/8.
All right, Ethan. Time to hear your voice in something other than a laugh. When is sine 1/2?
Oh, 60. 30.
30. All right, Ethan, when is sine negative?
Quadrant. I almost positive. Quadrants 3 and 4.
3 and 4. So we need the 30 that's in 3 and 4.
210, 330.
All right, Chris. When is sine 1 over 1?
0 degrees. 90 degrees.
90 degrees. That is only positive, so we're not going to say 270, just
0.
the 90. The 90. 5 omega answers on this one. Questions on number 10?
Stop now.
Just stop. How much?
Nope, there's more embarrassment to come. All right, number 11.
Man, Chris got to go.
Oh.
Mm.
As you're copying it, as I was copying it, I had 2 thoughts that went through my mind kind of simultaneously.
Changing it to
Number 11.
2 sine.
Number 11.
Changing it to 2 sine over 2 cosine on top.
Well, it wouldn't be 2 sine over 2 cosine, it'd be 2 sine over cosine.
And then
But
on the bottom, changing it to 1 over cosine squared.
I'd never had that thought, actually.
Oh, okay. I'm just gonna kill myself.
I saw a 2 tangent in the top, and my brain thought,
Tangent.
My brain thought 2 tangent over 1 minus tangent squared is double angle tangent. But the bottom isn't right. And then I saw secant squared, and I thought, wait, secant squared?
Pythagorean.
Pythagorean? What is the Pythagorean for secant squared?
1 times tangent squared, then whatever.
1 minus tangent squared. So let's rewrite this as 2 tangent over 2 minus 1 minus tangent squared. And now if we remove parentheses preceded by a negative,
Change all signs.
this is going to become,
-2.
well,
2 minus 1 plus tangent squared. So you can really just make it 1 plus tangent squared.
oh, excuse me, whoa, backtrack. What is the secant squared double angle? Or secant squared Pythagorean?
1 minus tangent equals 0.
No. That's the problem. Secant
It's
squared
1 plus tangent.
is 1 plus tangent squared, right? Secant squared is 1 plus tangent squared, which means that becomes a minus. All right. I was like, something's not right here. That's what it is. I copied it incorrectly. Secant squared is 1 plus tangent squared. And then 2 minus 1, of course, class is just
1.
So look at what I've got.
Another
2 tangent over 1 minus tangent squared.
Do it again.
That is the
Pythagorean.
No.
double angle tangent. Flip back to the front cover. Look at your double angles. Look at the tangent double angle identity. Refresh your brain. Yeah, there it is. So this becomes tangent of double phi equals 1. Which is a nice, harmless, easy-looking equation, isn't it?
No.
Watch it turn into something hard.
No, it can't, because we're practically done. We've got the trig function isolated.
Alright, put the 1 over 1.
We just said, when is tangent 1 over 1?
45.
45. When is it positive?
First and 3.
First and third. So what are my angles?
45, 2.5.
But we did make it a 2 phi, so I need to go around one more time.
4 or 5.
5, and
3 or 5 over 5. Ooh, I'm smart.
Well, that's 2 phi. I just want
Half.
phi. So,
202.5.
how about 22.5?
Yeah, that's what I meant. 22.5.
45?
Oh, yeah, we're on the top, yeah.
112.5.
Now,
And then you would have.
2.5.
202.5.
I joked you.
And then
292.5.
and there's my 4 phi answer.
Here's the one I admit I'm smarter than their calculator.
Alright, let me recap what we did. We replaced secant squared because it didn't match with tangent with its Pythagorean 1 plus tangent squared. Just remove parentheses, and all of a sudden we were left with 2 tangent over 1 minus tangent squared, which becomes the double angle. So here we formed a double angle, kind of like on number 7 from the homework. Remember we turned that into the cosine double angle? Well, here we turned this into tangent double angle, and then we finished it out pretty quickly. Let's see, we've got time for one more.
No, we don't.
Number 7, I think we do. Let's do number 17.
Oh my
No, we don't
goodness.
have this.
No!
No, stop.
Please don't.
You don't want to do this
No,
one?
please
What's
don't.
that about?
Do it.
Ah.
Let's do it.
Yeah,
There we
base
go, yeah.
And I'll kill your entire family.
Wait, what? Wait, what's different with shit?
I don't even care.
Is this a
I just don't like
vertification or
writing
what?
that. I just don't like writing that sign. Not.
I
Mu?
know,
Yeah.
I don't like you.
Mewtwo.
Be quiet.
You go up,
Yeah.
and then you make a U.
Yeah, but it's
I would start by going down.
Oh, no, start going up, and then make a U.
We just need to have a day dedicated to learning all of them.
Shut up.
This should be 3.
Alright, looks like we're doing
Do, oh,
Yeah,
should we?
nothing.
Cancel the 1 minus tangent mu to 1 minus tangent mu, or the tangent.
Distribute the 3.
Let's not.
Okay.
Let's do this instead. We see it's a proportion, right?
Yeah.
Over 1. Let's cross multiply, but let's do it the easy way. When we cross multiply here, let's literally leave it as that. And then when we cross multiply here, let's literally leave it as that. Let's not actually multiply anything together, just show the product of the means equals the product of the extremes. By the way, we should specify that this denominator doesn't equal
0.
so therefore,
Can't equal
1 cannot equal the tangent of mu. So if later on we get that the tangent equals 1, we're just going to cross it out. All right, now then, we've got one term here. We've got another term here. If we set the whole thing equal to 0, we could take this entire chunk of stuff. Imagine it's a 3xy. We just bring the 3xy over as a negative. But instead of a 3xy, it's a 3 tangent mu plus 1 minus tangent mu. Right? But if I bring it over, it becomes a negative, all equal to 0. But I still have 2 terms. And what is common to both terms?
tangent mu plus 1.
Tangent mu plus 1. So I can factor out
Oh my goodness.
the tangent mu plus 1. Now here's where it gets fun. What's left when I pull out tangent mu plus 1?
3 plus square root 3 minus 3 times 1 minus tangent mu.
Does that make sense? All right. Have I lost anyone yet? Still with me?
I'm always on.
Why can't we have just like catch them on both sides and cancel the tangent to mu plus 1?
Can't do
Ah, you can't cancel trig functions. So wait, stay with me. All right, so we factored out the tangent mu plus 1. Now let's simplify within this set of parentheses. So I'm going to bring that up here now. We still got the tangent mu plus 1 out front. If we simplify within the second set of parentheses, I don't need these two, right? And they're preceded by an understood positive. Let's just drop it 3 plus square root of 3. Here, what do I have to do with the negative 3? Distribute to get?
Negative 3 plus 3 tangent mu.
So we did distribute.
We do end up doing it, but not at the beginning because it would make everything harder. Does that make sense? But look inside that second set of parentheses.
3's cancel.
The positive 3 cancels with the negative 3. Notice they're not on opposite sides of the equal sign, they're together. And so I really just have, if we want to simplify it down, tangent mu plus 1 times the square root of 3 plus 3 tangent mu, all equal to 0. I've got two factors set equal to 0. Let's make two little equations.
Tangent mu equals -1. And tangent
Which
mu-
I'm going to put over 1.
Yeah, and tangent mu equals negative square root of 3 over 3.
Now, here's where your brain has to engage. Square root of 3 over 3 should look familiar, but this is a reduced form, a simplified form. What is this originally?
1
over square root of
3.
Negative 1 over square root of 3. When is tangent 1 over 1?
45.
45. When is it negative?
2 and 4.
2 and 4. So mu is
135 and 315.
all right. When is tangent 1 over square root of 3?
60. No. 45.
It's 30.
Opposite over adjacent. That'd be at 30. Okay, when is it negative?
Q.
Or 2 and 4.
2 and 4. So what's the quadrant 2 form of 30?
150.
And then quadrant 4.
330.
By the way, notice neither of these said the tangent was 1. It said it was negative 1, but that's not the same thing as 1. So all these answers are good to go. Questions here on 17. All right, homework. You got 4 of these. 4 of these homework. By the way, number 19 you're going to need your calculator for. Your homework is to do pages 144 to 145. Pages 144 to 145. Numbers 5, 8, 15, and 19. You will need your calculator for 19. So make sure you have that ready when you do your homework. I know normally we don't need it. We're going to need it for 19. We'll take a look at those 4 tomorrow as we continue on. Have a wonderful rest of your day. And you are dismissed.
Chrissy Jones.